everyone. My name is Connor Svensson. I'm here today to talk about Java development on Ethereum and Web3J. So, my company is a company called Block.io, and we're focused on bridging the gap between established enterprise technology and emergent blockchain technology. There's a lot of kind of plumbing and integration that kind of needs to be done in that middle layer there, and we're focused on building a lot of the tooling to help solve those problems, to really realize the potential that everyone talks about with respect to blockchain in enterprise and business environments. I'm also very involved in the Enterprise Ethereum Alliance, which is a body of a lot of the world's large corporates and small startups like myself as well, where we're focused on bringing standards together creating standards for Ethereum blockchain technology in an enterprise context. And so that's something that there's going to be a lot more, you'll be hearing a lot more about this year. Okay, so I'm going to start just by touching on Ethereum. Can I just ask if how many people in this room own Ether? Just put your hand up if you own some. Okay, so at least maybe about a third of the people here have some concepts of it. So there's really two ways that you can think about Ethereum. There's Ether, the underlying cryptocurrency, and as this graph shows, since it was launched back just over coming up to a couple of years ago, it's been in a wild ride, and right now I think it's somewhere around like $400, but it's very, very volatile, and the point here is that that's attracted a lot of speculators into the market. But of course, as a technologist, the aspect of it that is much more interesting to me is the underlying technology, and this is where you have Ethereum, the world computer. And this map is something that was put together midway through last year by one of the lead Ethereum client developers, where he just took the GPS coordinates of a number of different Ethereum nodes and plotted where they were running globally via Google Earth. And it presents kind of this nice view of Ethereum as this distributed computer with all these nodes running all over the place globally. So the blockchain itself, it's a decentralized immutable data store. So it's decentralized in the respect that there is no single entity that is responsible for it. It's a series of nodes running, it's made up of a number of peers all connected together, and they replicate, in effect, this data structure, which is like a singly linked list, which is your blockchain. Each entry on this singly linked list is called a block, and within a block you have transactions, and this is what this represents. Because it's a singly linked list where each block points to the previous block, so that you can work your way back up the blockchain to easily iterate over the history of it. So if you want to work with Ethereum or obtain Ether, the cryptocurrency, Ether's quite an important part of the whole thing of working with Ethereum. And in order to actually obtain it in the first place, there's a few different mechanisms that you can use to do this. One is, of course, is buying it, and those of you who've invested in Ethereum will no doubt be familiar with this process. But then there's also the option of mining it as well, which is a lot more fun, where you can build a machine with GPUs and so on to actually mine the cryptocurrency. Although as of the last couple of weeks, there's been some hardware that's come to market where people have created integrated circuits for mining Ethereum, so that aspect of it is probably going to be changing over the coming months. But the point is that as a starting point, you need to obtain some Ether to actually work with it. So in addition to Ether, this notion of having a computer, that Ethereum being a computer, it runs code like any other computer, and the code that it runs within what's called a smart contract. So a smart contract, it's really, it's code in the respect of what you think of code. So like in Java, it would be Java bytecode that can run on a virtual machine, and then there's state associated with it. And the idea is that when you run an operation on the blockchain, what's happening is that state transitions happen as the code runs to modifying the underlying state associated with those contracts that are running there. When you interact with Ethereum, there's a few different tasks that you can do. So one of them is send Ether from one person to another. Another option is to actually, push a smart contract sort of out to the blockchain. And then another is to actually call an existing smart contract and cause some sort of state change to actually happen to it. So there's 3 types of transactions there that you need to remember when you're working with Ethereum. And so in terms of what this actually looks like, this picture kind of represents the stages of what needs to be done in order to do that. So on the very far right of the diagram, you have this notion of a transaction, and then there's details about what you want to put in that transaction that reside there. So you'll have, say, if you're sending Ether to a person, you want to specify what's the address of where I'm sending this Ether to. If you're calling some code on the blockchain, you want to encode what the values are that you want to call that code with, in the same way that if you're just doing a method call, you're passing in parameter values. And then there's you need to think in terms of how much you're willing to pay for that transaction to execute on the Ethereum blockchain. So you take those parameters, then the next stage is you actually sign the transaction there. And so the signing process is where you do basically a digital signature. So it's a very well-established process using cryptographic libraries where, in effect, you have some data and you sign it cryptographically with your private key to, in effect, attest the data that's being published comes from you, and then that gets propagated out to the Ethereum network. So it then gets sent here to a client on the Ethereum network that then propagates it out to the nodes on the Ethereum network. Some of those nodes are miners, and then eventually this transaction will make its way into a block in a new block, which gets appended to the Ethereum blockchain. The thing is, though, this presents a number of different challenges. If we look at this diagram again, we can see that there's all this information that we need to encode into the transaction object. And then also, how do we actually know when the transaction itself has been appended to the blockchain? And so these are some of the integration challenges that application developers face. So one part of it is encoding and decoding of values. Another is that Ethereum by default uses 256-bit numeric type. So if you think about modern CPUs and the arithmetic there that's running on them, typically the abstractions that programming languages support will go up to 64-bit. The registers on some CPUs can hold more than that, like 128-bit values, but in terms of the abstractions of the programming languages like Java, you'll still think in terms of 64-bit values. There's multiple transaction types as well that you need to support. So in that previous diagram, that was how you perform a transaction. But if you want to send Ether versus deploy a smart contract or invoke an existing smart contract, these are all things that you need to change the input in order to do it. And then, of course, there's the management of the actual keys as well associated with it. So all of these factors kind of add up to actually create something of a headache if you just want to transact with Ethereum using kind of stock Ethereum APIs. And so this is where Web3j comes in. So Web3j is the Java library for integrating with Ethereum. The idea is that you can take any existing Java or Android or Kotlin, Scala, whatever you're using on the JVM, and you can use Web3j in order to talk to Ethereum using abstractions that are focused on what you're actually trying to accomplish, as opposed to having to dig down into these underlying semantics of the Ethereum virtual machine and the APIs that Ethereum nodes provide. So Web3j provides a complete JSON RPC API implementation. So if we look back at this diagram here, we've got this line here of your application with Web3j talking to an Ethereum client. That's using a protocol named JSON RPC, which is an RPC protocol that encodes data in a JSON payload. It's fairly straightforward to work with. But within Ethereum, your sort of client specification is all based on JSON RPC. It also supports Ethereum wallets as well, so you can create a wallet file and just load it into memory and then work with it. When you're working with a smart contract too, it creates smart contract bindings in Java. So once smart contracts have been written, you can deploy them, you can call them or whatever else, all from within Java code, rather than having to think about any sort of intermediate sort of representation or of that. There's also command line tools as well. So if you want to send Ether or create new wallet files and various other tasks, you can do all of that via Web3j, and it's Android compatible as well. So there's a Java 1.6 compliant branch of it for Android devs, and then you've got the Java 1.8 onwards branch too. At the end of last year, Web3j 3.0 came along, and so this added some significant changes. The first one was that it made the library modular. Now, it didn't make it modular in the sense of Java 9 modularity. I feel that at this point, it's you don't want to be forcing everyone onto Java 9's way of doing things when it's still relatively new, albeit we're already talking about Java 10. But the point there is that this modularity enables you to really pull out the parts of Web3j that you need in a very minimal way. So if you just want the logic for whatever reason to do transaction signing in Ethereum, but you don't care about all the smart contract wrappers or all this other stuff, you can pull that out. Or say you just want to be able to do a specific type of encoding which Ethereum uses behind the scenes, you can pull out the library for doing that in the form of a module, and so on and so forth. So it just gives you that flexibility to kind of cherry pick which components you need, but then you still have a core module which has most of the core sub-modules included within it. The API got updated as well, so you've got Web3j has always been provided as a synchronous and asynchronous API, but it also provides observables as well, which I'll talk about a bit more later. And then too, it's added in support for what's called the Ethereum naming service. So the Ethereum naming service is really, it's modeled on DNS. In DNS, you use a web address in order to remember what is to map it to an IP address. The idea with the Ethereum naming service is that you take a Ethereum wallet address, which is like 160 bits. Well, it's written as hex string, and you map that to a sort of common word with the suffix .eth. The idea being that then you don't have to think in terms of these lengthy wallet addresses, which no person could physically remember. And then it added support too for something called Truffle, which for JavaScript developers anyway, who might be developing smart contracts in Ethereum, you can develop them in Truffle, and then you can actually create the Java bindings from the work you've done using JavaScript as well. So it just gives you a bit more flexibility there. In terms of the artifacts, Web3j is available on all of the main repositories. So if you're on Android, then chances are you're going to be using JFrog bin tray, whereas if you're on Java using Maven, or you're likely to be using Nexus, and so all releases are put up there, so there's no problems pulling it down from corporate firewalls or anything like that, where there can be questions about just adding an arbitrary artifact repository to pull it down there. Command line tools as well get uploaded with every new release of Web3j, and then as well you can install it via Homebrew if you're on a Mac, the command line tools. One of the members of the community also made it available on one of the Linux distribution repos as well, so you can install the command line tools as well via on Linux machines using one of the package managers. There's a sample project, which is something that's got added recently to Web3j. Like historically, it's always had very good unit test coverage and had a decent number of integration tests out there for demonstrating all of the core functionality of the library. However, for people who are new to Ethereum, understanding what are the core things you can do without having to go deep into a whole load of code, I felt it was important to actually put a sample project out there. And so the idea with this sample project is that it enables you to use all of the core functionality of Ethereum. So send Ether to another party, deploy a smart contract, transact with a smart contract, read a value out of a smart contract, and then process what's called an event from a smart contract. But it does all of this stuff in a minimal amount of Java, so you can kind of get a feel for what you need to do all of these core things within Ethereum. In terms of the core modules, I mentioned that Web3j is very modular now. Just to give you a flavor, there's a number of different modules there. So at the start, we've got some base utility modules, and then we've got some encoding modules, and we've got our crypto ones. We've also got a tuples module as well, which It's like something that's always kind of annoyed me working with Java is the lack of support for tuples. Now, there is a tuples library out there which is fairly widely used, but then I thought, well, why not write a code generator that can generate an arbitrary size tuple library? So right now I think it supports up to 20, but using the code generators in Web3j, if you want to create your own tuples library that's got supports 100 member tuples or whatever, then it can do all of that. The point is though that I found that it was something that was useful and kind of needed in Java again and again, so it's worth pointing out that that's there. And then the other components, some of these modules are for taking advantage of specific features of different Ethereum clients that exist out there. So remembering all those different dots on the world map that I showed you at the start of the presentation, there's a number of different clients that are used for those dots. Some of them have got slightly different functionality. Okay, so Web3j saves you a lot of the hassle of transacting with Ethereum. So earlier on we saw a version of this diagram, but here I'm going to point out all the additional stuff that Web3j does for you so you don't have to kind of think about all of this. So previously we had this notion of a transaction, then we signed the transaction, then sent it through to Ethereum, but then we didn't hear anything else afterwards, sent it through to Ethereum. Now what we have is this nice API layer from Web3j. So you can specify, I want to perform a transaction where I send Ether. So let's call, transfer Ether. Say we want to deploy a smart contract, we can do just deploy smart contract, or we can call an existing method on a smart contract. We can do everything from within the Java code there that clearly states the intention of what we're trying to accomplish. It then goes through a similar sort of workflow as before. But the key thing is as well is that when you actually submit the transaction to Ethereum, what Web3j does, it's also got a transaction manager down here. So this transaction manager then continually polls the Ethereum blockchain to be made so that it knows when your block has been mined and added to the blockchain. So then at that point you can notify the client that it's taken place. Without Web3j, you'd have to write all of that polling logic yourself. You'd have to write all of the code to actually convert a transaction or a smart contract call or whatever else into the underlying transaction type. So it takes care of all of that for you, so you can just think about that layer sort of beyond Web3j. Okay, so if you want to get started with Ethereum, the first thing that you actually need is a client to work with. So if you want to do everything like yourself, then what you need to do is run a client on your command line. And so there's two main clients out there. One of them is called Geth, which is written in Go. You've also got one called Parity, which is written in Rust. And you just fire them up, and what they do is they then join the Ethereum network, and then they start syncing the blockchain from the other nodes on the network. The other thing that's worth pointing out, though, is that there's a service that enables you to run clients for free as well, called Infura. And so with Infura, you can it's basically AWS instances that you can hook up to, so you don't have to run these clients yourself. There's also some simulator clients too that you can run locally as well. But again, here we're talking about connecting to the real Ethereum networks. Then once we've got a client that we can connect to, the next thing we need is a wallet so that we can actually transact with the blockchain. So you need to have Ether in order to do anything with Ethereum. And so if you don't have a wallet, you've got nowhere to store any Ether when you get it. So you need to create a wallet. There's a number of different ways you can do it. But of course, we're talking about Web3j today, and Web3j is command line tools. You can generate a new Ethereum wallet file. So you just type Web3j wallet create. Then down here, you enter in, what you want to do is put in your wallet file password, and then where you actually want the file to be written. And then what it does is it creates a wallet file like this. And so the wallet file is just a JSON file which contains an encrypted Ethereum private key, basically. So at the very top, we've got an address which is 160 bits in length. Then we have the actual type of encryption cipher that was used for it. Then we have our ciphertext, which is our encrypted private key. And then we just have other information about the parameters that we use to actually encrypt the ciphertext. The public key can always be derived from the private keys, which is why you don't need to store what the public key is in this file. Then when you actually transact with Ethereum, if you're using one of the real Ethereum networks, it enables you to take advantage of block explorers for viewing the actual blockchain there. And so what you have is you've got Etherscan, which is one of the main ones, and you put in your wallet address, and then you can see details of all of the different transactions that are associated with that specific wallet. So the idea being that you can send some Ether to a wallet address, then you can view details of how much Ether you own in your wallet, and then any subsequent transactions that you perform, you can see details of them on Etherscan. Okay, so I've given you a bit of the background there, but if we're talking about wanting to actually start coding stuff up with Web3j, this is what we need to do. So we've included our dependency from from Nexus or wherever we pull it down from, and then we simply need to specify let's connect to a Ethereum client. So what we do is we say Web3j build, and then we specify where our client's running one on that we actually want to connect to. It defaults to the default location of where Ethereum clients run, and here it's connecting via HTTP, but you can also use IPC as well to connect to these clients too. Then the idea is that once you've got your Web3j instance, you just specify what method you want to invoke, any parameters if required, depending on what the method you want to call is, and then you can send a synchronous request. You can send an asynchronous request where you get back a completable future if you're on Java 8 or future if you're on Android. Or you can request an observable as well if you want to make use of the ReactiveX observable API, which I'll be coming on to. So here's like a really trivial example. Say we want to display the version of the Ethereum client that we're running on. This is the code to do it. So we start off by creating a new Web3j instance. Then we say, let's get our Web3 client version and send that request. And then we just print out the version, and then we can see down here details of the actual client that we're running. Then if we want to send some Ether from one address to another, it's a similar thing, except now we have the addition of a credentials object. And so what this is doing, this is loading your private key into memory from a file. So you give it the path to your wallet file, the password to decrypt it, and then it loads the private key into memory. Then what you can do is you can send some funds to an arbitrary address and say how much you actually want to send in Ether, and then it sends that through. So it's fun stuff to be doing, when you're playing around with the library, just seeing, seeing real crypto funds go from one person to another, from one entity to another, just with the code here. But the key thing is that once you've actually done that too, you get back this thing called a transaction hash, which uniquely identifies that transaction on the Ethereum blockchain. Then we take that transaction hash and we put it into something like Etherscan, and we can see details of the actual transaction that took place. Then you can also see details of the block that that transaction resides in as well. So we mentioned earlier on about smart contracts, and so we're going to talk a bit more about what smart contracts are and how you work with them. So they're usually written in a language that's called Solidity, and Solidity is a statically typed high-level language. People often refer to it as being a bit like JavaScript, but I think of it more, I'd say it's more Java-like, because at least it does have the static typing, and I think syntax-wise anyway, it is fairly straightforward to get your head around when you're coming from the JVM. But the thing is also, like Java, when you compile Java code, it generates Java bytecode. That Java bytecode gets interpreted by the Java virtual machine. Similar thing with Solidity and these other programming languages for writing smart contracts. You have the smart contract, it gets compiled into Ethereum virtual machine bytecode, then that bytecode gets processed by the Ethereum virtual machine. And so when you write these smart contracts, what you can do with Web3j is generate smart contract wrappers. So once the smart contracts are written in Solidity, everything else can be done within Java. So this is what a smart contract looks like. This one's called the Greeter, which is really your hello world in Ethereum. And so the idea here is that you've got contract, which you can think of it similar to a class level declaration. And so we've got the contract, which is called Greeter. We're saying it's mortal, sorry, Greeter is mortal, which basically means it's inheriting from this smart contract up here. And the key thing really to talk about here is that you have this Greeter method, which is a constructor, which takes a string value, and then that stores that string value as a, internally. And then you actually have a greet function that you can call on the smart contract to actually get the value out of that smart contract. So it's a very sort of simple example, but it gives you an idea anyway of what Solidity syntax looks like. So you have your smart contract, then the next thing you need to do is you need to compile the smart contract. So this is where you'd use Sol-C, which is the Solidity compiler. You specify where your smart contract's residing, the file that you want to compile, and then you generate a couple of outputs, which are binary outputs and what's called an ABI file. And these are both used collectively to actually then work with that smart contract in Ethereum. So the ABI file that gets generated, it's a JSON file that describes all of the functions or methods even that have been created on the smart contract and what the parameter values are that are taken by those methods. And this is a key, this is kind of like a map you can think of for actually then referencing smart contracts once they've been deployed to Ethereum. Then you have your binary file as well, which is just a lengthy piece of bytecode that gets interpreted by the Ethereum virtual machine. Then once you have those two artifacts, you can generate your smart contract wrappers. So what we do here is we use this Web3j Solidity generate. We specify where our binary file is. We specify where our ABI file is. We then specify what the package name we want to generate is, and then where we actually want this to be pushed out to. There is a Maven plugin and a Gradle plugin being worked on to help simplify this as well, because arguably it's something that could be nicely automated, so that you don't even have to do these steps here too. But once that's done, it generates a smart contract wrapper. There's also support using what's called Truffle as well. So Truffle is the main JavaScript library for developing smart contracts, and it's probably the most mature piece of software in the Ethereum space for writing smart contracts. And so you'll find what a lot of developers will do is they'll work with Truffle to actually create their smart contracts, and then from there they'll actually they can then bring them into Web3j, and Web3j can take what's called a Truffle metadata file in the same way it can take an ABI file or a binary file, and then it can generate these smart contract wrappers. And so this is what our generated smart contract looks like. You shouldn't have to think about what the code's doing under the hood, but it's interesting just to sort of give you a high level. So everything's extending like a base contract class, and then within that you have these are just different methods that have been defined on the actual smart contract. So this one greet here, which actually gets the value out of the smart contract, and then behind the scenes what it's doing is it's getting a value from the Ethereum virtual machine, it's decoding it into a what's called an ABI type, and then from there it's then converting it into a native Java type. The key thing here to point out is that we want to ensure type safety throughout the entire operation. So whenever we're pushing anything to Ethereum or reading it all back, everything goes from Java native types to Java representations of the native Ethereum types, then gets converted into the relevant bytecode, going there and back. So you have full type safety across every single step there, which, especially when you're talking about the blockchains as a store of value and everything else, it's important to take as much advantage of that as possible. And these are all wrapped in this remote call type, which is just an object that enables you to control whether you want a request to be synchronous, asynchronous, or use these reactive observables. So from this, we can create our hello world on the blockchain. And so we saw some of this code earlier on. So we create our new Web3j instance. Then what we do is we load our credentials into memory. Then when we've got that, we've generated our Greeter smart contract wrapper. And so there we pass in our credentials, and then we specify what string do we want to deploy in our smart contract. And then we send it. So what that's doing is that's taking our smart contract and deploying it out to the Ethereum blockchain. And those nodes across the Ethereum blockchain globally are then interpreting that code to actually create the smart contract with that specific value that you specified there, which is hello blockchain world. And then after that, we can call, in effect, a getter on it to say, what is our contract greeting? And we get that back there as hello blockchain world. So those 2 lines of code, they've actually deployed a smart contract to the Ethereum network, then read a value in the form of state from an existing smart contract in the Ethereum network. So it's quite cool to think about how the huge decentralized network that's running behind the scenes to actually accomplish this, given how trivial the example is. Okay, so you have your smart contracts, but what else can you do with them? One of the areas that has had a lot of attention and has really exploded, I guess, in the latter half of last year, was this notion of being able to represent some sort of asset on the blockchain. The things that blockchains, especially public blockchains, are very good at is creating a smart contract that represents some sort of physical or digital asset, and then manages the ownership of that asset manages the ownership of that asset and the actual associated provenance of it for individuals. The idea being is that you could say have an investor, they put money into a smart contract and they get a token back in return, and from there they can actually they have this digital asset that might represent something real or not, depending on what the people creating the smart contract are trying to accomplish. So, yeah, some of the examples here that's mentioned asset tokenization, but you do have standards that have appeared within the Ethereum landscape as well for this notion of how can you create reference contracts for tokenizing assets. And there's something called ERC20, which came out of what's called EIP20, which was an Ethereum improvement proposal for actually having a standard way of tokenizing these assets. There's some examples as well in the Web3j integration tests of this. But what it has given rise to as well is this notion of the ICO, or initial coin offering, and it astounds me when I see what the market capitalization of some of these firms are based on how much these crypto assets are trading for. This is from Etherscan. They have like a list of all of the different companies that have created that have done these coin offerings where they in effect give away part of their business to investors, or actually potentially not in the case of EOS, but they what they're doing anyway is that these are companies which are unicorns on paper based on how much their tokens are exchanging value for. But the underlying technology for this, all it is these it's basically smart contracts that manage tokens. People have put Ether into them and they get a digital token back, and that represents some ownership of their company or something that they're building down the line. But it's really exploded in the last 12 months. This whole space went crazy. Okay, so touched on the smart contracts and how to get going with Web3j. The other thing that I wanted to talk about was its usage of RxJava. So the RxJava library was something that came out of Netflix, and it's been around for a while now. But what it does is that they provide what they call observables, which is really a take on the observer pattern. But instead of having a single I guess entity that then you just calls all of these different subscribers every time an event happens, it just enables you to create things that can just emit a stream of events, and then you create processes that interact with all of those events as they take place. But this is a really nice abstraction for working with blockchains, because if you think that the blockchain's an immutable ledger, and Each block on the blockchain has a series of transactions in it, so it's an append-only data structure. And so if you want to listen to everything that's happening to the blockchain, the observable abstractions are a really nice way of doing that. And so for me, it just made sense to incorporate RxJava into the mix when I was developing Web3J. To really trivialize what you can do with it, you can just create a stock callback, but the idea is that you can have like a Web3J call, and then you can specify you want it to be an observable, and then you do the subscribe, and then you say, here's the call, well, here's the lambda or callback that I want to execute on that. But that gives rise to a lot of flexibility in terms of functional composition that can be done because you have these streams of events that you can kind of merge together and accomplish lots of cool things with. So with smart contracts, you can have what are called events. And so smart contracts, what you can do when you call a method on a smart contract, you can create what's called an event, which in effect is just like a log statement on the Ethereum blockchain that specifies some specific event having taken place. And so what Web3J enables you to do is to have observables that get called every time specific events take place on the blockchain. So say if you've got a smart contract that is used for managing tokens, like we heard earlier about this one called ERC20. And so what you can do here is you can have a listener so that every time in your smart contract a token gets transferred from one party to another, you've got a callback that can be executed there. So it gives you a really nice, simple way, whereas in a couple of lines of code, you can basically say, create some code to react to every time this specific event happens on a smart contract or on the Ethereum blockchain generally. It also gives you some nice APIs where you can just play around with the historical blockchain itself as well, rather than the actual smart contract. So say we want to process all new blocks on the blockchain, we just do this Web3J block observable, subscribe, and then every time a new block gets processed, we can print it out or do whatever we want to it. But it's really simple in that it's a couple of lines of code just to do all of your plumbing and then just say this is what's happening on the blockchain. We can also replay transactions as well. So if there's a range of historical transactions, say from transaction 10 to transaction 500, we can specify that range and we can easily reprocess them. We can also replay the entire history and also listen to all future blocks as well. So with the imaginatively titled Catch Up to Latest and Subscribe to New Blocks, we can replay the entire blockchain transaction history and then also all new blocks as well. So if you want to process the entire Ethereum blockchain, you can do it in a couple of lines of, well, a few lines of code to get all of the plumbing code up to actually do that. And then in terms of the performance as well, it's pretty reasonable. Like we're not, because the Ethereum blockchain, it creates new blocks every 15 seconds. So the sort of performance requirements you have when working with blockchain data sets versus some of the other data sets out there, unless you're trying to scan individual nodes and what they're all up to on the network, it's pretty reasonable to be able to replay the entire transaction history, as the test I did last year demonstrates. Web3J is made up of a number of different projects as well now. So obviously its initial creation was for Java and the JVM, and so it works really nicely with Kotlin, for instance, just because of its first-class support for interop with Java. There's also an Android branch that I mentioned. There's support for Quorum, which is a derivative of Geth for enterprises that came from JP Morgan originally. There's also Spring Boot Starter too, so if you just want to use some nice annotations and use Spring configuration to wire up Web3J, you can. There's a Maven plugin and there's also a Gradle plugin coming soon. Yeah, and so that's kind of a summary of it. So with the Spring Boot Starter, it means you can use auto-wired and all that sort of stuff as well. If you want further information about the project, really, if you head to web3j.io, that'll link to everything you need to see. There's links to like an early version of this talk. Also, the documentation is very comprehensive for the project too. There's lots of integration tests too. The sample project is probably the best place to get hacking on it, and the Gitter channel's got an active community of people working with it too. Thanks, everyone.